Let's talk about functions. This week we're looking at all different ways to create and use functions in JavaScript. And I'll quickly make you aware in the readings for week 2, I have links to a number of really excellent books, chapters on functions that I would recommend that you read. So in addition to reading through the notes that we have here, I'd also like you to take a look at these chapters and the guide to functions on MDN. A note about MDN. There are lots of different sources of documentation on the web about web development. But whenever possible, if you can, using this resource is going to give you the best options. These are documents that are written by Mozilla, but also by the wider web development community. It's an open wiki that lots of people contribute to, and the documentation is really, really good and up to date. So I would recommend taking a look at these books, taking a look at some of the docs that we have on MDN. Okay, so let's start out with a little bit of theory and some high-level ideas about functions. So what is a function? We could say that a function is some repeatable subprogram or a program that is defined inside of your program. We take a series of statements that we want to execute one after another, and a function lets us give that block of code a name. So one of the things that functions do is they allow us to make our programs more readable and therefore more maintainable. If I just have 1,000 lines of code and I have to start at the top and go down through it, it's really, really difficult to come back to that code later on and understand what it does. However, if I have 1,000 lines of code and it's broken up into smaller functions and each function has a really good name associated with it, that means that I don't even necessarily need to understand what each function does if I understand enough from the name. And so there's tricks like that we can use with functions to make it easier to understand what's going on in a big program. Functions, we could say, are also the smallest unit of code, this block of code. I'm going to use the term unit because you're going to hear me refer to things like unit testing later on. So a unit of code, we really can't or don't want to divide our program down into anything smaller than these units. And we could also say that really a function is a machine for transforming some kind of input that comes into the function, and what we're going to get is we're going to get some kind of output. So it's a box, a machine. It's this thing that transforms inputs into outputs. So in JavaScript, functions are perhaps more important than in a lot of other languages that you're going to be learning this term or in your time at Seneca. Functions are a first-class member of the language. So in the same way that we would work with strings or numbers in other languages, we're going to work with functions inside JavaScript the same way. So we're going to do some really interesting things. We're going to assign functions to variables. So we'll bind them to a variable. We will pass functions into other functions as arguments. We will return functions from other functions. We'll take functions and we will bind them to objects, and we'll create methods for doing object-oriented style programming. And we're going to find out that functions are actually objects in JavaScript. So anything you can do with an object, you can do on a function. For example, functions can have properties. Functions can have methods, which is kind of a hard idea to get your head around when you first begin. So JavaScript is a single-threaded programming language, which means that only one thing can happen at a time. As your program is executing, wherever the program is, whatever line or expression that it's evaluating at that time, that is the only thing that's happening, and there's no other, all the rest of the code is not happening at this one moment. So we break up complex logic in a JavaScript program into a series of smaller functions, and we let the runtime figure out when to do certain things. A very interesting way that we program in JavaScript, which you're going to find different from other environments you've been working in, is that we as programmers are often not in control of when our functions get executed. So we don't write a main function in JavaScript and then have everything else flow from that. Instead, what we're going to do is we're going to write a series of functions series of functions, and we're going to let the environment, so for example, the browser, we're going to let it decide when to do certain things. So imagine, for example, if I click on a button in a web page, I want some function to run. I want a piece of code to execute. So we're going to call this, later on, you're going to hear it referred to as event-driven programming. And so functions are the backbone of how we do this. Another thing I'm going to talk about this week is how scoping works in JavaScript. And we rely on functions in order to achieve some things that other languages make possible through more complex syntax in the language. So JavaScript has historically used functions as a way to hide data, to do data hiding, the way you would do it in classes or other languages, how they would use modules and so on. Speaking of modules, functions have been used in JavaScript to create various module systems. So for a long, long time, JavaScript didn't have a module system or a way to group a whole bunch of functions together into a module that was reusable. JavaScript has, later editions of ECMAScript have added modules, and so now it's possible, but we still have a legacy of using functions this way. And also, we're going to see how to use functions to create what are called closures, to capture and retain access to variables that would otherwise end their lifetime by going out of scope. JavaScript lets us do some interesting things by holding on to the scope of a value and not letting it get garbage collected. So I'll talk about all these things and I'll show you examples of them, but I wanted to set you up to understand that when you're going to learn to program in JavaScript, really getting comfortable with all the ways that functions work is going to be important, and it's going to take you some time. So I know that you've worked with functions in other languages. I'm going to add some things, and I'm going to extend the idea of a function. I'm also going to break some of your mental models about what a function is and what it can be used for. I'm going to try and teach you throughout the course the way to write functions in JS, in a lot of languages, and that is focus on writing small functions. You want to have a lot of small functions. Focus on giving them really good names. You're going to see me being incredibly anal about the names that you pick for your variables and your functions, because I want you to get good at creating maintainable code. And I want you to learn how to write functions that, when possible, don't have side effects. So it should be possible for us to call a function many times over and over and over again. And for a certain input, we should always get the same kind of output. So in JavaScript, where do the functions come from? Today we're going to talk about the fact that the language has a few built-in functions, but not very many. There's very few functions built into JavaScript. Most of the functions that we're going to work with come from one of a few places. So first of all, they come from global objects that are available in the environment. So the JavaScript runtime, the browser, or Node.js, or whatever it is that we're running in, it's going to provide to us objects which have functions living on them. So these are methods. We're also going to include third-party functions and third-party objects written by other JavaScript developers. So I showed you in a previous video the insane number of modules that have been written for JavaScript. There is code written in JavaScript to do everything you can imagine. And so it's really easy to integrate somebody else's code that they've written into a program that I'm writing if I don't want to write some piece of it. So we're going to use lots of third-party functions. And so these are user-defined functions. We can write our own functions. We can use functions that another developer will use. All right, so let's talk about some examples of these and just see how they work. So I'm going to skip down and do this out of order here in the notes. Again, I'm hoping that you've already read through the notes and we can just talk about certain aspects of things that are in here. So I want to talk about these built-in global functions. And what I'm going to do is I'm going to pop open my inspector, and I want to do a little bit of work here in the console to use these functions. So if you click on the link I've provided here, you can see the built-in functions that JavaScript has, and there's just a few of them. And some of them I would suggest that you should almost never use. Some of them are dangerous, like eval, for example. leads to lots of security bugs, and so it's not something that I want to encourage you to use. But there's a few of them in here. So let me show you an example of some of these and just how they work. Okay, so let's take parseInt as an example. So whenever you're working with one of these built-in functions, I again want to get you used to the idea of going directly to solid documentation. Nobody remembers all of the syntax and all of the ways that you're supposed to call these functions. I've been programming JavaScript for forever, and I have to look this stuff up all the time. I can't remember everything because unless you use it every day, you forget. So what I want you to do is I want you to go to the docs, look things up. So if I was going to use parseInt, I could go and look up the documentation on MDN, and it'll show me a number of examples of ways that I could call it, and it'll also show me the syntax. So it'll say, for example, parseInt takes a string, and it also takes a radix. So the string is whatever value you want to parse. So I have a string that is a number, is an integer, and I want to parse it into a proper numeric type. And the radix is essentially the base. So we're going to typically want to work in base 10. So we would define and say that this is, we want to do something in base 10. So for example, if I say parseInt and I give a string, so I give the number 5 and I give a base of 10, when I press enter, you see that what I get back is I get back the number 5. And if I did that again, I could say what is the type of the return value that I get back from this? The type is a number. So some of the built-in functions that we have available to us, Parse Float is similar. If I parse a float, I can say 31.5, let's say, and it'll give me back that. If I were to ask the type of parse float 31.5, you can see that it's also number. So remember that in JavaScript, the only numeric type that we have is number. So a number is a double precision floating point number. Even though we don't see the extra decimals here, they're there in terms of the way that JavaScript thinks about them. I won't go through all these, but I wanted to talk about how we call them. So these functions are just available globally. So you can just call these functions and they will work. So here's another one. I'll talk about these ones because they're kind of interesting. Encode Uri Component. If I have a string 1, 2, 3 like that, I can encode it so that it would work as part of a URL or a URI. So if I was going to put this onto a URL, URLs can't contain spaces. So you'll see, for example, that the space that this string has in it has been encoded, percent encoded into %20. If I put some other character in here, if I put like ampersand in here, you'll see that it has encoded that %26 is how this gets encoded. So there are certain functions in the language for being able to convert between types and code things from one type to another. If I were to take this string and I wanted to get it back again, I could do decode Uri component and it would give me back that string. So as I say, there aren't very many standard built-in functions. JavaScript is famous for having a very, very small standard library and a very small set of built-in things that you can do. JavaScript delegates the responsibility of all the functionality that you would want. It says that this code should be written by other people. So rather than having it in the language, it is defined outside the language, which has pluses and minuses. So there are some languages that have a really rich built-in system of standard functions and objects and so on, and you don't have to reach very far to be able to do it. However, you also end up being a lot more limited because those things get shipped with the language, they get updated with the language. So there's a lot, it's a slower movement on making those things, having changes to them or updating them. Okay, so there's another set of functions that we can work with. And these are functions that live on, let me jump to the notes. These are functions that live on objects. So a lot of the JavaScript that we're going to do, I'll just show you examples here, is going to be object-oriented in nature. And so we're going to be taking an object and we're going to be calling a function that lives on the object. So we typically refer to this as a method. You'll hear about methods in Java and C++ and so on. JavaScript has methods as well. And so these are functions that live on objects. So as an example, we could talk about the console. So our very first program that we wrote looked like this: console.log hello world. So here what I'm doing is I am working with the console object. If I look at the console object is an object that has a whole bunch of different methods. You can see all these purple methods that are here. One of them is the log method. So these are functions. You can see the F. These are functions that live on the console object. Now, these functions are implemented inside of the runtime that I'm in. So they're being provided to me, in this case, by the browser. And these are going to be written in, so if I were to look at console.log, console.log is implemented as part of the browser or part of the environment. It's probably written in C++. It's not necessarily written in JavaScript. So this is important because JavaScript's meant to be embedded inside of an environment like a web browser. And that browser or that environment can provide implementations for objects like the console object directly to the language. So console isn't built into the language as such. It's a global object that's available to me. So console.log or console.warn. You can see that my warning looks a little bit different than my log here. Or if I were to say console.error, and I'd say that I have some error, you can see that my error looks different again. So the fact that it has a different color, the fact that it comes out looking a little bit different, that's all part of how each of these functions is implemented in the environment that we're working on. And I would encourage you to go and take a look through the kinds of things you can do with console. The console has all kinds of methods on it that do really cool things. Like, for example, console has a count method. And the way that it works is that you can give it a label and it will tell you how many times that label has been called. So for example, here you can see it saying console count user. And as it hits this with a particular value each time, it prints out this has been called once, twice, 3 times. There's lots of little neat features like that. Or being able to, let's find another interesting one, console.table. Console.table lets you print out this tabular view of your data so you can debug it and figure out what's going on when you're trying to understand your code. So I won't go through all of these things today, but there's lots and lots of things you can do with the functions that live on console. We have similar objects that we can work with in the form of things like math. So math provides things like constants, so math.py, and it also provides things like random. So if I wanted to get a random number between 0 and 1, every time I call this, I'm going to get a different random number that I could work with. Date, similar kind of thing. So if I say date.now, it's going to tell me the number of milliseconds that have elapsed since January 1st, 1970. Every time I call this, you'll see that number is going up. And so I'm able to get, the current time, as it were, the way my computer sees it in terms of looking at this in milliseconds. So we have lots and lots of these built-in objects, and we're going to talk about them in coming weeks. I'm not going to spend a ton of time on them today because I more want to focus on the structure of functions, how to write them, and all the different ways that you can create them. And when we talk about object-oriented programming in JavaScript in a couple of weeks, I'll come back to these things. But for now, I want you to know that if you ever need to do something with math, you go to the math object. If you need to do something with dates, you go to the date object, etc. Something with JSON, which we'll talk about later in the course, you go to the JSON object. Okay, so we've said that there are built-in functions like Parse Float. There are functions that live on global objects like date and math and console. And then there are user-defined functions. And user-defined functions are the thing that I'm most interested in spending time on and talking about today. So we can write our own functions to extend the language. We can write functions to add features. We can write functions to extend what the environment can do. So JavaScript is incredibly powerful because you can program the environment that you're in. You can modify the program as it's running. So there's a lot of things that are possible in a dynamic language like JavaScript where data types can change. You can move things around really easily. You can redefine things really easily. And you can write implementations for functions that might be missing in a particular environment. So I'm going to show you examples of all the different ways that we can do this. So let's dive into this. I'm going to switch over here, and I've got an editor open so that I can write a little bit of code and we can talk about it. Okay. So how do I write a function? There's a number of ways to do it. I want to show you all of these different ways. And the first one that we're going to talk about is what's called a function declaration. So when we declare a function, what we have to do is we first of all need to use the function keyword, and we need to give it a name, like so. Okay. So a couple of things to note about how you define a function. The first thing is the way that you do your names. So when you write names in JavaScript, what I want you to do is I want you to use what's called camel case. Camel case says that you always have the first letter lowercase, and then every letter thereafter is going to be uppercase like that. So some languages write their names like they use snake case like that. So this is common in Python, for example. Some languages use kebab case, where you'll have a dash in between. We're going to do that a lot in CSS and HTML. And some languages prefer really short names, really long names. Java uses really long names. So for JavaScript, I want you to get into the habit of writing everything in camel case. And this should really be some kind of an action word. Whatever your function is doing, so your function is going to do something. So because it's going to do something, you should name your function so that it's clear what it does. Remember that the name of the function has a number of roles. It's going to help you understand your program much quicker if you can name this thing properly. So for example, if this is a function which will generate a password for a user, that's what I want you to name it. So you're not limited. Your functions names don't have to be 3 characters long. I definitely don't want to see stuff like this. Function 1, function 2, function 3. If you're doing that, you know you're doing it wrong. You never ever should be doing this. You want to try and be clear in how you're going to name this thing. So we have a function which is going to do something. Now that is a complete function definition, and already you may be, having an allergic reaction to this because there's some things that are missing. So, for example, we don't specify a return type. So our function doesn't have a return type there. We don't say like int at the front of it. We don't do that. So we don't have static typing in JavaScript. JavaScript has types, but they are runtime types. So the type that this function returns is not known until runtime when it actually returns a type. So we'll talk about this. Another thing that you don't see here right now are any arguments. We're going to talk about how to put arguments in here, but in the simplest form, we could write a function like this, do something, and this is a valid function. Okay, so let's talk about the other styles of functions that we have available to us. So this is a declaration. Another really common way to do functions in JavaScript is to write what are called function expressions. So an expression in JavaScript is this: 1 + 1 is equal to 2, or if I say something like encode Uri component A plus space plus B, like these are expressions. So an expression is taking a series of statements and it is evaluating it down to a single value. So this expression is evaluating down to a number. This expression here is evaluating down to a string. A function expression evaluates down to what's called a function object. Okay? So a function expression returns a function object. And a function object is something that can be passed around in a program, or it can be assigned to different variables in your program. It's similar to a function declaration, but it's used in situations where you want to bind something to a variable. So let me give you an example. So if I were to say let f equals 7, we know what that means. It means that I want to take this literal value 7 and I want to bind it to f. So now f refers to that. What if I said that f is equal to 7 plus 1? Well, in this case, what I have is I have this expression, which I'm putting in parentheses just to show it. I have this expression, and JavaScript's going to evaluate that expression down to a single value, and it's going to return that back over here. So f is going to be equal to 8, which is the value of this expression. Now think about this. What on earth does that say? Well, at first blush, it's going to look really weird and it's not going to make sense, but I want you to take it apart a little bit at a time. So what are we doing here? We're saying f is a variable, and I want f to be bound to the right-hand side of this expression. On the right-hand side of this, what I have is a function expression. So a function expression means that this thing is going to evaluate down to a function object, which means that f is going to be equal to this function. So let me show you what I mean here. Let's go over here and write some code. So if I were to say let greeting equals function what does this mean? This says define a function which returns the string hello. Or if we wanted to, we could put a name in here. We could say return hello plus name. We could do something like that. So say hello to this person. Now when I press enter here, I have greeting, and I'm gonna do this. When I type greeting, what does it give me back? It's evaluating greeting, and it's saying that greeting is this function right here. So we've defined a function, and we've assigned that function to the greeting variable. How do I call that function? I use the execution operator. So if I say greeting versus greeting, if you think about the difference between those two things, greeting says, get me the value that is stored at greeting. What is the value that's stored at greeting? It's this function. And when I invoke it by using the invocation operator here, and I execute that function, then it's going to run that function and I'm going to have access to it. So let's change our function around a little bit here. Let's write a function called add. And I'm going to extend add so that it has a couple of arguments. So I'm going to pass in A and B, and I'm going to return A plus B, like that. How would I call this function? Well, I could say let total equals add 1 and 1. And here total is going to equal 2, right? If I was to rewrite this code down here, I could say let add equal function A, B, return A and B, like so. So both of these are equivalent. So I have a function declaration which defines add as a function that takes two arguments, adds them together, and returns the result. I have another function down here which is being defined as a function expression. Now notice something interesting about this. There is no name here. So this thing here that we're creating from here down, we call an anonymous function, or a name that doesn't have a function that doesn't have a name. Why would I not put a name on my function? Well, I could if I wanted to. I could say function add. That would also be valid. But you'll see people lots of times just working with these no-name functions. And it's going to seem really weird because obviously we need a name in order to call this function. So let's say I'm going to call this add2. A moment ago I told you not to do this, and I don't want you to do it. So do as I say, not as I do. But I want to differentiate between add as a function declaration and add version 2, which is written as a function expression. How would I call add versus 2? Add version 2. I would say add2, 1, and 1. And that would give me back a total of 2. So I have these two different styles of defining functions. And I want you to be aware of both of them. You're going to see me use both of them a lot when I'm creating functions, and they're useful in different scenarios. So let's go back to greeting for a second. Greeting is a function, right? Calling greeting with the invocation operator runs the function which is stored at greeting. Let me ask you something. What would happen if I did this? Let G equals greeting. What does that say? Well, we said that greeting refers to this function object which has been defined. This function expression has created a function object, so it's in memory, and I'm saying let G equals greeting. So let's look at a similar piece of code for a second. Is if I said x equals 1, let y equals x, what does that mean? Well, the value of x, right, y we would assume is now equal to the same value that we had for x. So if we were to evaluate G, we would assume that G is referring to the same function that was defined by greeting. So indeed, if I said G and I said G Dave, it gives me back that same value. So one of the things that's interesting about being able to work with these function expressions is that I'm able to define a function and then bind it to a variable, and then I can use that to pass it around and reuse it in different parts of my program. So you're going to see me talking about function declarations, which look like this, just a bare function on its own like that, and function expressions, where I am putting the definition of the function on the right-hand side of an assignment, or I'm using it in a function call, or I'm using it in a place where you would expect an expression to be. Notice one more difference here. You see how I have a semicolon here, but I don't have a semicolon on line 5. So function declarations don't end in a semicolon, but a function expression does have a semicolon at the end. And what you're doing is you're defining that this expression has been completed. So it's done. Okay. All right, so let's talk about one last type of function definition that you will see. So this is the first one. This is the second one. And the third one is what's called an arrow function. So I'm not going to spend a ton of time using these because I think they're a little bit more advanced, but I want to make you aware of them. So as much as I can, I'm going to try and show you things that are evolving in JavaScript. JavaScript is changing all the time. They're getting new features, new syntax. So I want you to be aware of it. Even if you don't use these right away, eventually you will either start using them yourself or you will see people that you're programming with, they will use them. And I want you to know how to read them. Okay, so let's take this function. Let's take this and rework it. So this is our function expression. I'm going to do a third version of the add function. So this time what I'm going to do is, in order to show you what's happening here, I'm going to put this all on a single line, like so. Now, over the years, we've had to, as JavaScript programmers, write lots of code that looks like this. And programmers are lazy. Programmers invent new syntax all the time in order to have to type less, basically. They don't want to type more than they have to. So there is a new syntax that has come out, and I'll just copy this so we can compare. So this new syntax looks like this. I'm going to get rid of the function keyword, and I'm going to leave the list of parameters or arguments that are going to get passed to this function. And what I'm going to do is I'm going to insert what's called a fat arrow. So an equal sign and this greater than sign together, they call a fat arrow. And so this thing we refer to as an arrow function. So what this says is add 3 is equal to this function expression, and it takes 2 arguments, A and B, and then this is the body of the body of the function. So in this case, the only thing my body is doing is it's returning A plus B. So with arrow functions, what I can do is I can actually get rid of the return keyword. So an arrow function automatically returns the result of evaluating this expression. So if this syntax does not feel comfortable to you, ignore it. You don't need to use it. And you can stick to these earlier syntaxes here for now. Later on, when you're a little more comfortable, you'll come back to this and you'll see it. I'm going to use it sometimes, but I find I don't want to confuse you. And so I will probably stick to function declarations and function expressions when I'm writing this, when I'm writing my code. Okay. All right, let's talk about a couple more things, and then what I want to do is I want to write some examples with you. So a couple more pieces of theory that we should talk about. So I'm going to delete this for now and just focus on this function right here. So let's talk about return values. So if I have a function, let's say my function is called do something, and it looks like this. And if I say let x equals do something, 1 and 2, what does x equal? So what I want you to know is that every function in JavaScript returns a value. They all return a value. They either return a value explicitly with the return keyword, or they return something implicitly. So here, I have no code here. However, there is an implicit return statement. So it's implied. Even though you can't see it, there's a return statement here. And really what it is returning is undefined. So the value of x here, x is undefined. Let me show you, let me prove it to you. So if I have a function do something, and I say let, say x is equal to do something, the value of x is undefined. Type of x is undefined. So if you don't return something from a function, the return value is going to be undefined. Now, a lot of times what we'll do is we'll use that by, we won't assign it to anything. So we'll write a function and we will call the function, but we'll throw away the return value. So you don't have to use the return value that comes back from a function if you don't care about it. Okay, what if I did this? What if I did this? What is the return value now? Well, the difference is that I now have an explicit return statement. So it's clear that my code is returning undefined. And my code could return other things. My code could return 0, for example. So what's the return type of do something now? It's a number. It's the number 0. Or we could do what we said before, a plus b, like so. We can return a plus b. Let me ask you a question. If I do this, what is the value of value? Well, it would be 1 plus 2 is equal to 3, and it would be a number. What would the return type be this time? I have 2 strings, and I pass them into do something, and do something is going to add them together. Well, if you add 2 strings together, you're going to concatenate them. So in this case, I'm going to get back the string A and B, and the type is going to be a string. So JavaScript has runtime typing. Depending on the value that you return, or depending on the value of the pieces that you're working with, your arguments and so on, you're going to have different results. So you have to be careful about managing this data as it's going through your functions, going through your program. All right, let me say something else about return statements. A habit that you have had pounded into you in languages like C and C++ is that you should only ever have one, So you only ever have one single return at the end of a function. Now there's reasons that you do that in a language like C and C++. So the reason that C and C++ do this is because often before you can return the value, you have to do some kind of cleanup. Like for example, you might have to free some memory. And if you have multiple returns, if you return here and you return here, the problem you're going to have is that you're going to not do your cleanup code. So a lot of languages that need to do manual memory management have to be very, very careful about how many exits they have from the function. And so that's one of the reasons that you've been taught to do it this way. But in JavaScript, you don't have to do this. In JavaScript, it's fine for you to have multiple return values inside of a function. And we're going to do this lots and lots of times. So you can return early, return as many times as you need to. And so it's very common in JavaScript programs and in the style of writing idiomatic JavaScript to see lots and lots of different returns as you're going through. So when I do the examples, I'll show you some examples of this so that you're clear on what's going on. Okay, let's talk about one more aspect of this, and that is what about the arguments that I pass to my function? So if we have A and B and we return A plus B, tell me something. What will that do? What happens if I call my function and I pass it 3 arguments instead of 2 arguments? Will it work? Can I do this? The answer in JavaScript is yes, you can do this. JavaScript allows you to call a function with any number of arguments and any type of argument. So this is a perfectly legal program. You can do this. You could put as many as you want on here and there'll be no problem. So take a look at this, for example. What does this do? Console.log 1, 2, 3, 4, 5. So you'll notice that console.log console.log lets you pass any number of arguments and any type of argument. So I have a string, I have a number, I have a Boolean, and what's this? This is a function expression. I have a function expression, and it will print all of them out. So console.log is an example of what I'm talking about, where in JavaScript, you can pass as many arguments as you want to a function, and it won't break things. It's perfectly fine to do this. Now, what's going to happen up here is I'm just going to ignore all of those other functions that are being passed in. I'm just going to ignore them. Now, let me ask you this. What would happen in this program? So we have the opposite problem now. Instead of passing, more arguments that I need, I'm passing in fewer arguments than my function is expecting. So this is a thing that we have to deal with a lot in JavaScript. What is the value of A right here? Well, if I did this, what is the value of A if I did that? It's undefined, right? So we can prove this to ourselves. If I said let A, and I look at A, you can see that the value of A is undefined. So the value of A here is undefined, and the value of B here is undefined because we haven't passed any values in. What if I did this? What if I said 1? So I pass in 1, but not 2. So if I say, what is 1 plus B? Well, B is undefined. What would that be? We could test it out. We could say 1 plus undefined is equal to this special type called not a number, NaN. So this is an error. We don't want to do this. We want to be very careful. And so in JavaScript, we have a lot of freedom to use different data types, to pass things around dynamically, to use more or fewer arguments than we need. So we have to write our code in a defensive way to be able to handle working with this. So let me show you some tricks. Okay, so let's say that I wanted to write a function. Let's say add. And I'd like add to work like this. I'd like to be able to say console.log add 1, 2, 3, 4. And I'd also like to be able to say add 1 and 2. So I want to be able to call add, but I want to give it any number of arguments. How am I going to do this? Well, you might say to me, okay, Dave, what I'm going to do is I'm going to make this work for 4 arguments because I notice that the most you use is 4. And you know what I'm going to do. I'm going to obviously do that, and I'm going to add 1 more. And now I'm going to break and you're like, okay, well, no problem. I'll just add 1 more. But this is eventually it's not going to work. So how do we solve this problem? We know that JavaScript allows us to pass any number of arguments to a function. So inside of my code, it's possible for me to access those using a special object called arguments. So every function has this special variable that you don't see it declared anywhere. It's just part of the function. And arguments is like an array that has all of the arguments that have been passed to you. So let's do the following. Let's make a variable total, set it equal to 0. Let's write a loop. I is less than, how do I know how many arguments there are? I ask the object to tell me how many there are. So I say arguments dot length. So the length is a property of the arguments object. So I'm going to take total and I'm going to add to it, total equals total plus, I'm going to add to it arguments at I, whoops, like so. And then when I'm done, I'm going to return total like that. So if well, let's test this out. I'm going to paste this over here. So I'm going to add 1 and 2, and it's going to give me back 3. I'm going to add 1, 34, 56, 78, and it's going to give me back 169. What if I pass it in 3.56? Okay, so now I get back a floating point. So it's working for all of these different things. Okay, so we have a function that works a lot like console.log. This function doesn't define any arguments. We don't say A, B, C. Instead, what we do is we use the arguments. And you're going to do both things. So a lot of times you're going to write functions and you want to take exactly 2 arguments. And so you're going to give those functions a name. However, if you don't know how many you want and you want to be able to receive lots and lots of these things, then what you're going to do is you're going to use arguments. Now, there is a new addition to JavaScript to make this a little bit cleaner, and we can use what's called a REST parameter. So you're going to see some people write their code like this. So when you see this, it means that I want to take basically the rest of the parameters that are inside of here, and I want to call them numbers. I want to make something called numbers. So the only difference this is going to make to my code is I'm going to say numbers, and I'm going to say numbers like this. And the benefit of this is it helps to document your code a little bit more. It's clear that you are expecting to receive a whole bunch of numbers here because we've documented. When I leave it off like this, it's a little bit less clear what your intent was. And so that you can do it. You can do it with arguments, or you can do it by saying ... numbers. Okay, so I think what I'm going to do is I'm going to pause this discussion there. There's more I want to talk about, but I think I'm going to do the rest of it in the context of some examples. So in the next video, I'm going to write at the bottom of the notes for this week, all the way down here, there's a whole bunch of practice exercises. So I'm going to implement a few of these, and we can just talk about some of the design choices we might make for writing these functions and go over some examples of the kinds of things that we just did.